Hello students, welcome back to the classroom point. In today's class, we shall discuss the volume strength of the hydrogen peroxide. This makes the students more confused while solving these questions using the hydrogen peroxide and when hydrogen peroxide is used in the titrations. So let's make the concept very easy. Now let's begin it. Volume strength of hydrogen peroxide. So the definition of the volume strength of the hydrogen peroxide is it is the volume of oxygen liberated by 1 liter of hydrogen peroxide at STP. So whatever the volume of oxygen is released by 1 liter of hydrogen peroxide is called its volume strength. Let us take some examples here. So example, imagine if 10 volumes of H2O2, if any bottle is labeled like this 10V, so this stands for, so means that so this 10 stands for the actually volume of oxygen released by 1 liter of the H2O2. So 10 volumes of H2O2 means that 10 liters of O2 is released by 1 liter of H2O2 at STP. Now let us take what happens if 20 volumes of H2O2 is mentioned. So it means that again 20 liters of oxygen is released by 1 liter of H2O2 at STP. Now if a bottle is having the 30 volumes of H2O2, so this means again that it is releasing the 30 liters of oxygen by 1 liter of H2O2 at STP. Now let us see here, what about if XV is mentioned? That means XV of H2O2 stands for X liters of H2O2 is released by 1 liter of H2O2 at STP. So let us see why H2O2 is releasing the oxygen. If we see the reaction, we will come to know why decomposition reaction, how decomposition reaction is going to take place. H2O2 decomposes to the H2O plus half moles of oxygen gas. Now, if you see this reaction, how many moles of oxygen is released? Only just half mole of oxygen. Half mole of oxygen gas is released from the 1 mole of H2O2. Half mole of oxygen gas at STP occupies 11.2 liters. That means 11.2 liters of oxygen gas is released by 1 mole of H2O2 at STP. Then if X volumes if we take, so X liters of oxygen is released by how many moles of the H2O2? That means number of moles of H2O2 is equals to, do the cross multiplication, X into 1 mole divided by 11.2, so that we can write down that X divided by 11.2 moles. Now let us try to relate this number of moles. What is the important one what we got here? So this can be connected to the remaining all the formulas. Now let us see relation with molarity and normality. We know that molarity is equals to number of moles by volume of solution in liters. Every time the volume of the H2O2 is only 1 liter we have taken here. So here H2O2 volume is also is equals to 1 liter. So if you want the molarity of the H2O2, is equals to number of moles of H2O2 is X divided by 11.2 into 1 liter. So this is molarity is equals to X by 11.2. What is the meaning of X here? See, starting only we said that X means volume strength. Whatever the 10V, 20V, 30V we are using the words, these stands for the volume strength. So obviously XV is also stands for the volume strength. So that's why in the place of X, now I am writing the volume strength. So I will mention the volume strength as Vs. So volume strength is equals to molarity into 11.2. We also know that molarity, normality is equals to molarity into n factor, and molarity equals to normality divided by n factor. N factor of H2O2 is equals to 2. So let us substitute these values there. So we get the volume strength of H2O2 equals to normality divided by 2 into 11.2. It goes 5.6 times. That's why volume strength of the H2O2 equals to normality into 5.6. Like this we can calculate. See, these are all important formulas. There are only 4 to 5 formulas are there. If you learn these formulas carefully, and you shall be able to solve the questions. So let us relate the same concept to the strength. So now let us see the strength. The definition of the strength is nothing but the mass of solute dissolved in a liter of solution is called as its strength. That means grams per liter means mass per liter volume. So now let us see the same molarity formula. Molarity equals to, we know that, weight by molecular weight into 1 by volume of the solution in liters. This mass by volume says about the strength. So in the place of this I am writing the strength. So molecular weight you bring this side, it becomes molarity into molecular weight, so that we can write down the strength of H2O2 is equals to molarity into molecular weight. Molecular weight of H2O2 is 34. So that's why we can write down that strength of H2O2 equals to molarity into 34. The same thing, if you want to convert this molarity, if you want to use the normality in the place of the molarity, you know that molarity equals normality by n factor here. So that's why strength of H2O2 is equals to normality by 2 into 34. It goes 17 times. That is the reason why strength of H2O2 equals to normality into 17. These are important formulas for us. Volume strength, 2 formulas. Strength, 2 formulas. In case of the volume strength, very simple. This molarity and normality is multiplied by the volume. 11.2 liters, 5.6 liters. In case of the strength, where we are using the mass, that's why we have to multiply the molarity and normality by mass. What is the mass? Molecular mass here. Molecular mass of H2O is 34 and here it is 17. Why? Because we are taking the gram equivalents, or else 34 by 2 equals to equivalent mass we are taking, that's why equals to it is 17. Next, let us relate the same thing with the percentage weight by volume of H2O2. So these are very simple to relate. Percentage weight by volume of H2O2 is equals to strength of H2O2 divided by 10. What is the strength of H2O2? Molarity into 34. So that we can write down that molarity into 34 divided by 10, or else simply you can write down molarity into 3.4. That is percentage weight by volume of H2O2. Now, let us try to make another relation how this strength and volume strength are related. So, let us see here, volume strength is equals to, so here we can write down that relation between strength and volume strength. Volume strength is equals to molarity into 11.2. So that molarity equals to volume strength divided by 11.2. Whereas strength of H2O2 equals to molarity into 34. So in the place of molarity, now molarity equals to, we can write down that strength of H2O2 divided by 34. In the place of molarity, now I will write down the strength of H2O2 divided by 34. So that I will get strength of H2O2 divided by 34 equals to volume strength divided by 11.2. So that you can interconvert the strength into the volume strength and volume strength into the strength. I hope you understand. Now let's make some problems and the questions and how to implement these formulas in solving the questions. So there is a question here. Find the molarity, normality, strength, means grams per liters, percent by weight by volume of 10 volumes of H2O2. So here 10V stands for the volume strength. So now let us see the solution. Volume strength of the given H2O2 is just 10. So we also know that. Now let us try to find out one by one term. So volume strength is equals to molarity into 11.2. They asked the molarity. So molarity equals to volume strength by 11.2. Volume strength is 10. So 10 divided by 11.2. Hopefully it will be 0.9 approximately. Next, normality. So we know that volume strength equals to normality into 5.6. So normality equals to volume strength is 10 divided by 5.6. Strength of H2O2. So that strength of H2O2 equals to molarity into molecular mass. Molarity already here we calculated, that is 10 divided by 11.2 into 34 is the strength of H2O2. Percentage by strength. So that here we can do that percentage weight by volume of H2O2 is equals to strength of H2O2 divided by 10. Strength of H2O2 divided by 10, whereas strength of H2O2 here we did the calculation 10 into 34 divided by 11.2 into 10, 10 cancel out, 34 divided by 11.2. So let's move on to the another question. So the second question is 100 ml of H2O2 reacts completely with 15.8 grams of KMnO4 in acidic medium. Find the volume strength of H2O2 given molecular weight of KMnO4 is given as 158. So last time only in last class we discussed that how to use the number of gram equivalents. Every time we have to use the number of gram equivalents for the titrations and the redox reactions. If you don't watch that class, please do watch that and come back to here. Now let us see here. Solution. Here KMnO4 and H2O2 both are used. So let us take the KMnO4 on one side and H2O2 on the other side. That means the number of gram equivalents of the KMnO4 now I am making equals to the number of gram equivalents of the H2O2. Number of gram equivalents n into n factor equals to n into n factor. See here, they asked about the volume strength of the H2O2. So let us try to calculate the molarity of the H2O2. Here, number of moles value not given but mass is given. So we can write down the weight by molecular weight into n factor equals to here number of moles. Number of moles means again you can, because they ask the volume strength, no? So we can write in the molarity into volume in liter into n factor. But here volume of the H2O2 is given in the milliliters. So that's why to convert this liters into milliliters, divide with 1000. So let us substitute everything here. Weight of KMnO4 given as 15.8 grams. Molecular weight is 158 grams. Into n factor of the KMnO4 in acidic medium is 5. And molarity to be calculated. Volume of H2O2 given 100 ml divided by 1000 into n factor of H2O2 is equals to 2. Now molarity equals to 15.8 into 5 divided by 158 into 1000 divided by 100 into 2. So that now here it cancels like this. It goes 0.1 times and it goes 2.5 times. So that here molarity is equals to this is 2.5, this 0.1, 10 cancel out. So molarity is equals to 2.5. Now they are asking the volume strength. Volume strength of H2O2 is equals to molarity into 11.2. Molarity is 2.5 into 11.2. Let us try to solve that. 2.5 into 11.2 equals to 28 is the volume strength. So let us solve some more questions. Question number 3. Calculate the strength of (20V) solution of hydrogen peroxide H2O2. So strength they are asking and volume strength is given. So the solution, already we have made a relation, strength of H2O2 divided by 34 equals to volume strength divided by volume. Strength means molecular mass, volume strength means volume. So volume strength is given. Now they are asking the strength. So strength of H2O2 equals to volume strength value 20 into 34 divided by 11.2. So let me make the calculation easy. 20 into 34 divided by 11.2 equals to 60.71. Is the strength of the H2O2. Now let's go to the another question. Next question. A bottle of H2O2 is labeled as 10 VH2O2, 112 ml of this solution of H2O2 is titrated against 0.04 m acidified solution of KMnO4. The volume of KMnO4 in liter required is. So I'll erase this side now to make this space available. So here, let us solve the question. Again, KMnO4, H2O2, same concept. KMnO4 number of gram equivalents equals to number of gram equivalents of the hydrogen peroxide. So here, N into N factor of KMnO4 equals to N into N factor of the hydrogen peroxide. Volume strength is given, that is 10 V. So here they are asking 112 m of the solution is used against the, so volume of the KMnO4 they are asking, and the molarity of the KMnO4 is also given. So let us convert this number of moles into molarity into volume into N factor equals to, so here molarity into volume into N factor of H2O2. So molarity value is given. Solution value they are asking in the liters. Here the value is given in the milliliters, so it has to be divided by 1000. So now molarity, let us substitute these values. 0.04 into volume of KMnO4 to be calculated. N factor of KMnO4 equals to 5, and here molarity of the H2O2 not given. So here volume strength is given. Volume strength is equals to molarity into 11.2. So molarity equals to volume strength by 11.2. Volume strength is 10 divided by 11.2. This value is substituted here. That is 10 divided by 11.2 into volume, that is 112 ml divided by 1000 into N factor value of the hydrogen peroxide is 2. So that volume of KMnO4 equals to 10 into 112 into 2 divided by 11.2 into 1000 into the entire value becomes the denominator the other side. So 1 upon 0.04 into 5. So let me make the solution here. 10 into 112 into 2 equals to divided by 11.2 equals to divided by 1000 equals to divided by 0.04 equals to divided by 5, that equals to 1 liter. The answer is 1 liter of KMnO4 is required. So let's make the another question. Question number 5. See, X grams of H2O2 requires 100 ml of M divided by 5 KMnO4 in titration in a solution having pOH equals to 1. So they're asking which of the, means what is the value of X? pOH equals to 1 means it is basic medium. So in basic medium, N factor of KMnO4 is equals to 1. N factor calculations we already did in the previous classes. Please do watch that class. So now KMnO4 number of gram equivalents equals to number of gram equivalents of the hydrogen peroxide. N into N factor of KMnO4, N into N factor of the hydrogen peroxide. So molarity into volume into N factor here. This is weight by molecular weight into N factor. Here volume of the KMnO4 is given in the milliliters, so that divide with 1000. So molarity of the KMnO4 is given as 1 upon 5 into volume is given as 100. N factor value is 1 divided by 1000 is equals to weight, we don't know, molecular mass 34, N factor value is equals to 2. So it goes 17 times and here there is a cancellation. Then let us try to get it. Weight of KMnO4 equals to, do the cross multiplication, bring the 17 here. So that 17 by 50. So weight equals to 0.34 grams. So this is the answer. So let's make another question to be solved. Question number 6. 100 ml of 0.01 m KMnO4 oxidizes 100 ml of H2O2 in acidic medium. Volume of same KMnO4 required in alkaline medium to oxidize 100 ml of same H2O2 will be. So this is the question. So first of all, acidic medium calculations, let us try to perform it. Solution in acidic medium. Now, number of gram equivalents of KMnO4 equals to number of gram equivalents of the hydrogen peroxide. N into N factor equals to N into N factor. So here, regarding the KMnO4, volume is given, molarity is given. H2O2, only volume is given. Let us try to find out the molarity. So that here, molarity, volume into n factor of KMnO4 equals to molarity into volume and n factor of the hydrogen peroxide. Volumes of the both KMnO4 and hydrogen peroxide is same, so that volumes cancel out. Molarity of the KMnO4 is given as 0.01 into its n factor is 5. Molarity of the H2O2 to be calculated into n factor equals to 2. So here it is 2.5. Molarity equals to 2.5 into 10 power minus 2. That is of H2O2. Now let us use in the basic medium. In basic medium, again use it KMnO4, number of gram equivalents equals to H2O2. But in basic medium, KMnO4, n factor value already we have seen that it is 1. So that here again n into n factor of KMnO4 equals to n into n factor of the H2O2. See here they asked volume of same KMnO4 required. Same means concentration of the KMnO4 remains same. So molarity into volume into n factor equals to molarity into volume into n factor. See, volume of H2O2 is given in the milliliters. So let us try to divide by 1000. So here molarity of the KMnO4 is 0.01 into volume of the KMnO4 that we have to calculate. N factor value is equals to 1. Here molarity of the KMnO4, here we did the calculation, that is 2.5 into 10 power minus 2 into volume is equals to 10 power 2 divided by 1000 into n factor of the KMnO4, sorry, hydrogen peroxide equals to 2. So 10 power minus 2, 10 power 2 cancel out. Now you just write down the volume is equals to, this multiplication gives 5 divided by 10 power 3 and this becomes 10 power minus 2 and it becomes 10 power 2. So volume is equals to 5 into 10 power 2 into 10 power minus 3. 10 power minus 2, 10 power minus 2, 10 power 2. Correct only. So that here it is equals to, volume is equals to 0.5 liters, or else you will get the 500 ml. This is the answer. I hope you find the video very helpful. If you really feel this is helpful, please do like the video and share it with your friends. And if you have any doubts, please do write to the classroom point@gmail.com. Thank you and all.